Okay, let's unpack this. If you run a major corporation, right, and you need to know if your new product is going to fly off the shelves, you are sinking millions, maybe even billions, into consumer research, polling thousands of people, usually asking them for, a simple 5-point Likert rating to gauge purchase intent. But here's the catch, and it's a big one.
We know those traditional human panels. They're incredibly noisy.
Oh, they really are, yeah. The data you get back is constantly being, let's say, contaminated by just inherent human stuff. Things like acquiescence bias, where people just kind of agree with things, or that classic positivity bias, where everything gets rated a bit higher than maybe it should be. We spend huge amounts of resources, frankly, on pretty flawed data collection.
And that reality, that noise, that's what really set the stage for this big promise of AI, using large language models, LLMs, as well as synthetic consumers. Exactly. The core idea is pretty brilliant on the surface. You condition a model on a detailed demographic persona, say a 30-year-old mother of two, middle income, whatever fits your target. You show it your product concept, and you just ask its opinion. Simple.
Seems simple.
Yeah.
But those initial attempts, they kind of failed, spectacularly even, especially when researchers tried the most obvious method, just asking for that Likert number directly, direct Likert rating, or DLR.
Yeah, that first wave, it was fundamentally broken. And it wasn't because the models themselves weren't capable, It was the method they used to get the answer out. It just forced them into this, unnatural, inconsistent outputting. But now there's a solution, something that seems to fundamentally repair this error. It's called Semantic Similarity Rating, SSR.
And that is our mission for this deep dive. We're going right in to understand how this SSR thing actually works. Why shifting from asking for a number to asking for, free text was the key. And critically, how this innovation managed to achieve over 90% of human retest reliability. That's huge. It's what finally makes synthetic panels seem like a truly viable, maybe even superior tool for massive scale consumer research.
Okay, so we established the promise. LLMs could maybe cut through the noise of human panels. But when they first tried, the models basically choked. What exactly went wrong when they tried that simple 1 to 5 scale?
Well, the DLR approach, the direct Likert rating, it was kind of like trying to sit a square peg in a round hole, scientifically speaking. Researchers would give the LLM the persona, the product concept, and then they literally just asked it. And people output a single digit. 1, 2, 3, 4, or 5.
Yeah, the LLM just couldn't handle the finality of that, of picking one single number. Exactly, the distributions of those numbers, they came out, weird. Either really, really narrow, or highly systematic in a way that just didn't match human data, or just plain inconsistent. The model showed what the researchers called a safe regression to the center of the scale.
Meaning?
Meaning, if you looked at the raw data, the LLMs mostly just answered 3, the neutral value. They almost never used the extremes, 1 or 5. Super raw in their responses.
And that's the exact opposite of what you see in real consumer data, right?
Right.
Especially in concept testing. If a product has any legs at all, people tend to cluster around 4 and 5. They get positive.
Precisely. So the model was just playing it safe, giving these middle-of-the-road answers.
Okay, so if the answers were all bunched in the middle, how did that actually translate into, performance metrics? Did it tell you anything useful?
It produced this kind of paradoxical result, actually. On one hand, the correlation attainment.
Which is how well it ranks products against each other.
Right. That was actually decent. Models like GPT-4o and Gem2F, they were around 80% accurate at ranking. So they could generally tell you, concept A is probably better received than concept B.
Okay, but ranking isn't everything. Companies need to know the level of excitement too, don't they? The absolute intent.
Exactly right. And that's where DLR just completely fell apart. The distributional similarity, which tells us if the shape of the response curve looks like real humans, that was terrible. They measure it using the Kolmogorov-Smirnov statistic, KS for short. For GPT-4o, the KS similarity was something like 0.26.
Wow, okay. Not good.
Not good at all. Gem2F did a bit better, maybe 0.39, but still. That's a catastrophic failure. It means the model just couldn't replicate how consumers actually respond.
So let me get this straight. The LLM using DLR was sort of right on relative preference A is better than B, but it was fundamentally wrong on absolute behavior. It couldn't express real enthusiasm because it wouldn't use those 4s and 5s.
You got it. And that failure meant you couldn't trust the output for, say, market size forecasts or sales projections based on that skewed distribution. It was useless for that.
Which leads us directly to the big idea. Semantic Similarity Rating, SSR. This was the conceptual breakthrough.
Yeah, the key insight was realizing, okay, LLMs are amazing at generating natural language, right? That's their strength. But they really struggle when you force them into this kind of arbitrary, discrete number constraint. So SSR flips the script. It leverages the model's strength text generation and then uses the language itself to figure out the rating.
Okay, walk us through that. How does SSR work, step by step?
Right. It starts with step 1, textual elicitation. So instead of asking for a 4, you prompt the LLM to just talk, to generate a free text statement. Based on the persona and the product concept, what's its purchase intent? The response might be something like, I'm somewhat interested, but I'd really need to see the price before I decide.
Ah, okay, so you get a rich qualitative statement first. Makes sense. What's next?
Step 2 is embedding. You take that free text response and you feed it into a separate, highly optimized embedding model. The research used text embedding 3 small. Its job is just to translate the meaning of that sentence into a mathematical vector, an embedding vector.
Okay, so the intention is now mathematically encoded in this, like, high-dimensional space. Then what?
Then step 3, similarity mapping. This is where it gets clever. You compare that response vector to a set of predefined static reference statements, or anchor statements. You have one anchor statement for each Likert point 1 through 5. For example, the anchor for 5 is always the same. It is very likely I will buy this product. You calculate the cosine similarity, basically. How close in meaning is the LLM's text to each of those 5 anchors?
I see. So that gives you a score showing how semantically close the LLM actual response is to say definitely will buy versus might buy versus definitely won't buy.
Exactly. And that leads to the final, really critical step, generating a response probability mass function, or PMF. This is where SSR really differs. It doesn't force the LLM's response into just one integer. Instead, the output is a distribution of probabilities across the whole 5-point scale. So if the LLM's free text is, say, 80% similar to the anchor statement for 4 and maybe 20% similar to the anchor for 4, the final output reflects that ambiguity. It gives you a much more nuanced and, it turns out, realistic prediction than just forcing it to pick 4.
Hold on a sec. That sounds, well, a lot more complicated than just getting a single number like with DLR. We went from one simple integer output to free text generation, then vector embedding, then similarity mapping, then this probability distribution calculation. If you're a company trying to screen hundreds, maybe thousands of concepts, does all that extra computation, that latency, really scale? Doesn't that undermine the whole scalable promise?
That's a really important question. And yes, DLR is definitely simpler computationally, but its output is, frankly, useless for understanding the true distribution. SSR is a multi-step pipeline, no doubt. But 2 things. First, the cost of LLM inference has dropped dramatically. It's much cheaper now. And more importantly, the cost of generating, say, 10,000 synthetic responses using SSR, even with all those steps, is still just a tiny fraction of the cost of actually recruiting, managing, and processing a human panel of 10,000 people, especially when you factor in all the data cleaning and trying to correct for those biases we talked about earlier.
Okay, so you're trading a bit more upfront computation time for a massive improvement in data quality and relevance.
Precisely. We trade a small computational cost for a huge leap in fidelity. The scalability isn't just about speed per response. It's about how many concepts you can reliably screen before you have to spend the big bucks on human validation.
Fair point. If the data quality is truly high enough, then that upfront cost pays for itself downstream by saving you from testing duds with real people. Which brings us neatly to the validation. Here's where it gets really interesting. After all that clever engineering, did SSR actually deliver on that promise of high fidelity? Did it work?
It absolutely did, yeah. The researchers put it through its paces. They tested SSR across 57 real-world consumer research surveys. These were for actual personal care product concepts, and they had the ground truth. 9,300 real human responses for those same concepts. The results were pretty conclusive. Synthetic consumers using SSR were finally looking like a valid tool.
Okay, let's break that down. First, reliability. How well did the synthetic responses reproduce the relative product rankings compared to humans?
Amazingly well. SSR managed to recover the relative ranking of those product concepts with really high accuracy. We're talking correlation attainment, that's the metric, basically mirroring human test-retest reliability, which, remember, is itself noisy. GPT-4o hit 90.2% reliability. GEM2F got 90.6%. That essentially proves the synthetic ranking signal is robust, it's trustworthy, it meets most commercial standards for just screening concepts.
Wow. So if the human panel itself is only about 90% reliable from one test to the next because of its own noise, achieving parity with that is actually a massive milestone. Okay, But the real test, the thing DLR failed so badly on, was fixing that skewed output, the distributional realism. Did SSR finally produce response distributions that looked like real people?
Yes, this was the monumental success, fixing that core problem. Remember that failure baseline for DLR, KS similarity, around 0.26. Using SSR, GPT-4o achieved a dollar of 88.
88, that's huge jump.
Massive jump. And Gem2F hit 0.80. What this means is the synthetic panels were generating response distributions that included that vital positive skew, the realistic cluster around 4 and 5 that signifies real interest. This makes the absolute purchase intent metrics finally usable for things like market prediction.
And you didn't just compare SSR to the flawed DLR method. You also compared it to a traditional supervised machine learning model, right? A light GBM classifier. Why is it such a big deal that SSR, which needs no training data, it's zero shot, actually outperformed a model trained specifically for this task?
Yes, that's a crucial point for practical application. The light GBM classifier was trained directly on features extracted from the same product concepts. It had seen the data, essentially, but it only managed a reliability that ranking score boasts of about 65%.
Much lower than SSR's 90%.
Much lower. Now, its distributional similarity was actually pretty good, around soft 8 cents, similar to Gem2F with SSR. But its ability to correctly rank the products, significantly worse than SSR. And SSR achieved its 90% ranking and high distributional similarity as a zero-shot method. It requires absolutely no previous survey data, no fine-tuning on your specific problem, yet it synthesized human-like responses more effectively than a supervised ML model that was specifically optimized for the task. That makes SSR instantly deployable. You can use it across pretty much any category where the base LLM has general background knowledge. And beyond just the raw numbers, the research gave us some really fascinating glimpses into how these LLMs actually process the product concepts, especially when you give them those demographic details, the personas.
Right, the persona seems critical for getting useful results.
Yeah.
But how accurately did the synthetic consumers mimic real human nuances based on demographics?
Surprisingly well, actually. The LLMs, when they were acting as these personas, they replicated some pretty complex human patterns. For instance, with age, they showed this sort of concave purchase intent pattern, meaning the middle-aged personas tended to rate concepts higher than the very young or the very old personas, which is a known pattern in human data for lots of product types. They also correctly reflected lower purchase intent when the persona was explicitly given, say, budgetary constraints related to their income level.
That really shows the persona isn't just flavor text. The model is actively using it to shape its response. But I remember reading about that experiment where they tried decoupling the persona from the distribution, the no demographics test. That revealed a really critical trade-off, didn't it?
Oh, absolutely. It revealed something fundamental about how the LLM forms preferences. When they took away the detailed persona prompt, just gave it the product concept, the distributional similarity, it actually became nearly perfect. It hit an incredible 0.91. It matched the mean, the standard deviation of the real human data, almost flawlessly.
Okay, wait. So if the main goal was just to perfectly replicate the shape of the human response curve, taking the persona out was the answer. That seems backwards. Why was that considered a failure for practical use?
Because while the shape was perfect, the correlation attainment, the ranking ability just plummeted. It fell to only 50%.
Ouch. So random chance, basically.
Pretty much. It means the model achieved that perfect distribution shape by essentially ignoring the specific details of the product concepts. Without the persona acting as sort of an anchor or maybe a filter for relevance, the LLM just defaulted to some kind of generic, generally positive distribution, but it completely failed to engage with what made product A different from product B. The detailed persona is absolutely the critical link. It forces the LLM to actually use the product information and generate a meaningful signal for ranking.
And thinking back to the SSR process, because it requires the model to generate free text first anyway.
Right.
You automatically get this stream of qualitative data baked right in.
That's a massive bonus. You know how human open-ended survey answers can be. Often super lazy, it's good, I like the smell, not very helpful.
Right, minimal effort.
Yeah, but the synthetic consumers, they consistently provided much richer, more detailed qualitative feedback in their free text responses. They'd highlight specific features they liked or disliked. They'd raise explicit concerns, often quite nuanced ones. We saw examples in the research, like a persona writing, that a concept seems kind of bougie for this kind of product. That gives you immediate, actionable rationale behind why it might have given a lower rating.
That kind of detailed feedback is gold for product iteration. And it sounds like this depth combined with maybe the LLM having less of that human positivity bias, provides a clearer, more discriminating signal overall.
It certainly seems to. It means companies can potentially rely on these richer signals to iterate concepts much faster. You screen them synthetically first using SSR, get both the quantitative ranking and the qualitative Y, and then you only commit your expensive human panel validation into the small handful of concepts that SSR flags as genuinely promising.
Okay, so summing up the practical value here, SSR looks like a genuine plug-and-play research tool. Needs no fine-tuning, no prior training data. It solves that core elicitation problem that stopped earlier synthetic panels from working properly. And it dramatically speeds up the concept screening pipeline by giving you this high-fidelity, dual-channel feedback, the quantitative rank and the qualitative reasoning.
Yeah, if we step back and connect this to the bigger picture, this SSR methodology really legitimizes synthetic consumer panels as a credible approach. It directly addresses and resolves those fundamental reliability and realism issues that, frankly, prevented these models from being used seriously in commerce before. This framework could really be a blueprint for augmenting and maybe eventually significantly accelerating how companies generate consumer insights across loads of different industries.
So what does this all mean for you, the listener?
Well, it's important to note the context. This research focused heavily on personal care products. These are categories where LLMs tend to have vast amounts of public training data reviews, discussions, blogs, etc. The success of SSR is probably, to some extent, bounded by that LLM training domain. It's likely not a universal substitute for all human research just yet, especially in maybe highly niche B2B areas or for radically new product categories where there's just not much public discussion for the LLM to have learned from.
That's a critical boundary condition to keep in mind, yeah. We have to remember the model can only really reflect preferences if it's been exposed to the underlying context and language of those preferences during its own massive training phase. Right. But let's end with a final provocative thought for you to chew on. Since this SSR method seems to generate results that are demonstrably less biased, more reliable point-to-point, and qualitatively much richer than the often noisy data we get from traditional human surveys, could we see a future where consumer research eventually relies on these SSR-validated synthetic panels as the actual baseline, the gold standard for measuring consumer perception? Maybe instead of just augmenting human data, they become the benchmark against which human data is compared. Something to think about. What new rapid-fire research avenues could this kind of zero-shot tool unlock for you and your organization?